Hello everyone. Last class I have introduced you the WebGL, and in this class I'm going to introduce you the more advanced function of the 3D WebGIS multi-source data loading and the flying browsing scene. So first, let's review the structure of the WebGL objects for you. And the basic class is the viewer. And viewer is a basic component used to build the application, and the entry point, the whole point for the development. And this is an organization chart, structure. The scene is a base. The scene is the most often we used, and we can add the corresponding data. For example, the primitive can add some dynamic layer and S3M instance, and the primitive and the model objects. And the terrain provider can add terrain data, and the image layers, image grid layers can add the image data, and the layers can add the S3M tiles layer. And all of these are added to the viewer through the node of the scene. And there also have the entity. It's mainly loaded stretch objects, which are very similar to primitives. And the difference is that the entity has a higher degree of the primitives, which is directly added to the viewer to display. And the info box is a message pop-up window which can display the message directly in the scene. And the camera objects provides the camera's perspective and finds a suitable perspective for the observer to browse the loaded data. And the data source collection is a collection of the data source which can be divided into 3 tabs: the CZML and KML and GeoJson. And these 3 tabs of the asking process can be added to the viewer to display. Okay, that's our structure. And using entity to load the entity objects, and it includes a scene, entity, info box, camera, data source collection, and that's our structure. First, let's look at our how to load the S3M cache layer. It's mainly to load our 3D tile cache, the S3M layer, and mainly includes the tide, and it can be loaded as a 3D tile cache, the .s3m format. And so for the data, we could use this method to add the oblique photography model, and the BIM, and the point cloud data, and the refine model, and the vector data, and so on. So, and we will use the scene.add S3M tiles layer by SCP. So through this name of this interface, we can understand that by SCP is to enter the this URL and there's some options in our code. Okay, so let's look at how to write this code. So first, obtain the S3M layer service address. This address must be include the config file and add the S3M layer service and set the camera angle of view and convert coordinates. And let's look at its code. And we can see at here the first parameters is to pass the address of our corresponding service. So for this data, we will use CBD data. Okay, and then enter our corresponding in this URL. The address of the configuration file and the layer, and then you can pass the corresponding parameters of the data and you want to add it through the these options. It's first add its service address and then add our layer service, and finally add its name, and finally add the camera perspective so that our perspective can be positioned to the corresponding layer and can be positioned to the successful loading, because we can open the scene through the scene.open. Then the view angle saved in the workspace will be loaded directly, and the corresponding view angle can be set by the S3M tail layer. So if we wanted to set its camera, we should use this. And then we will be in the view with the 3D scene, and we will not be able to observe whether our data has been successfully loaded. Okay, so that is our code. The first is to obtain the BIM data service address and load the building layer, and the second step is to pass the corresponding address through the interface scene.add S3M tail layer by ICP, and give the attribute of the layer name, which is the name of which is a building CBD. And after then the third step are load and pass the promise of the parameters of the surface just add through the system.1, and then pass him a callback function, and then set its camera's perspective through the scene.camera.setView. Scene.camera.setView, and then this destination is through system discourse conversation, the cartesian coordinate system, and the conversion method is a coordinate system from the to convert the coordinates passed in x, y, and z to make a comparison between the setting the camera's angle of view and not setting it. So it is So if we don't set it, that is that's default board. So this destination is across the system.cartesian3 from degree to set its coordinates of the x, y, and z. Okay, this is a little example to loading the S3M layers, S3M cache layer. Okay, and then let's do our first exercise to building a 3D urban scene on the web. So the data we will use the iServer's own CBD data service, and we will add the 3D building model and add the city trees and add the city lakes. So okay, and then let's open the code that I have sent to you. It's named add data and entities. Okay, that is a code that I have completed. Okay, so for the first part is use this scene.open to add our CBD file. And let's look at in our website. Okay, and to tap our localhost. Localhost is 090 hello world and add data and entities. So and to ensure that that HTML file is in your web apps, is in your folder of the web apps. Okay, and ensure that its HTML is in the hello world. Okay, and that is the way we use this code to add the CBD data. And then that is our exercise 1. So I'm gonna give you some minutes to complete this exercise. Okay, and then that is to load the terrain data. So we can see this code. We can see this code here. The service address of the corresponding data is passed through the system terrain provider method, and there is an attribute of whether to turn on the water surface effect. If you want to turn on the water surface mask, and you should set it true, because the default is false. And the whether to enable to the normal attribute and this ISSCT. And whether to enable the normal attribute ISSCT. If it's to add a server terrain surface, it should be set to true. Okay, that is more important. The terrain service is divided from the supermap as server and needed to set the ISSCT to true when you publish. And after passing in the corresponding parameters and pass them to the viewer. Okay, and then let's come back to our code. Let's annotation this code, this part of code. Annotation is part of code, and comment this terrain code. And comment this terrain code. Okay, and save it. And let's open our browser and refresh it. Let's look at that is the way to add our terrain data, and it's use the system.system terrain provider, and uses URL and set its ISSCT to add the terrain provider. Okay, and because we are now set its camera, and let's look at where is our data. It is maybe in there, and you can look at. This is our terrain data. This is also our terrain data because we don't add its image, so that is our terrain data. We can see that's the relation of this terrain data. Okay, so I will give you minutes to tap this code to again and fill this code. Okay, and let's come back to our PowerPoint, and then I'm gonna to introduce you how to load the image data. The image data is uses a system.supermap image grid provider to add in the code. So for this API interface, you can find it in our API documentation. And for the it uses system.supermap image grid provider to add in the browser, and pass the address, pass the URL of your data. And the image grid provider transfer to the add image grid provider this method, and through this image grid layer to set the image grid layer, and use this fly tool to fly to the layer. And if you don't know the coordinate value, you can use this fly tool. You don't to find your terrain and image data. And there also have the zoom tool that is a fly, and another is a panning. So the fly tool is a fly to your data, and the zoom tool is a zoom to your data. And that is a different in your visual. That is a different in your visual. So that's image data. It's use system.supermap image grid provider, and use image grid provider to transfer to the add the layer provider, and use the fly tool to fly to the image grid layer. And that is the data tab of the image support. It provides supported data tabs of the loading, include WMS, Supermap, REST, and TMS, WMTS, ArcGIS, or something. Okay, and then let's look at the image grid data, the code of the image grid provider. Okay, and let's uncomment this image grid code. Okay, that is as an image service published by the Supermap as server, and it uses a fly to layer. And let's save it and browse it in our browser. Okay, we can refresh it and fly to the to our data. Okay, because the internet it may be a little slow. We can see we add our image data and the terrain data, so it has the duration and has a color of this terrain. So we have successfully added this image data, and you can tap it again and to fill this code, and I will give you 1 minute. So in this class, maybe I don't have some time to tap this code with you, and I hope you can tap this code by yourself, and that's the best way to learn the programming language. Okay, I will give you 1 minute. Okay, and let's look at the next. It's a KML file. The KML can contain the elements such as a point, line, area, landmarkers, models, animation models, or something. So for the KML file, we should add it to our directory folder, and we just directly load our file. So we can see this code. We could use this href elements to add our KML file. And it can also be passed in the loaded method through the data collection object that I've mentioned in the structure of the WebGL object structure just I mentioned for you. So data source collection. It's through the method of the load, and it's passed to we can see it's through this load, and to add the URL of the folder of the object folder to our code, and it's use a viewer.datasource.add method, and through the construction, the system, the KML data source, system.kml data source, and through the method of the load to add this KML file from the projected file, and transfer the corresponding URL to set its camera and the canvas, and then that's it, which adds some cameras perspective, and set the latitude and the longitude orientation, and set some pitch angle, and so on. So let's look at our code now. Okay, and then let's look at our code. To uncommon the terrain and the image part, and uncommon the KML file. Okay, and that's our code of the KML. It uses scene.camera.setWheel, and uses a viewer.datasource.add to add our directory of our KML, and we can look at our KML. Okay, and then let's find our KML file, this Korean file, and add it to our folder of the data. Add it to our folder of the data, and let's look at its directory. It's in the KML Korean. So let's create a KML folder and add this Korean KML file to this data. It's in the Hello World data-KML, and there have the Korean. Okay, and then let's saved it, and refresh our page. Okay, and we can see we are successfully at this KML data. We can see that it's still an animation model. Okay, and that is a KML file. And then let's look at go back to our PowerPoint to look at how to load the GeoJSON file. So if we have some vector data and its format is a GeoJSON file, we could use this code to edit. And GeoJSON is more general network vector data transmission screen, and the loading method is as follows. It uses the data source .add method, and it's the same as the KML file, and it's use the system.geojson data source.load method, and it passed the directory of the data, and it set its stroken, and set its wise, and set its fill. It set its fill as right and with alpha, and set its collect to the ground. Okay, and then let's look at the code of the GeoJSON. And then let's comment this KML and comment this GeoJSON data. We can see it use data source.add and passed its directory of this Taiwan.geojson, and set its stroken fill and altitude mode. Okay, and then let's refresh our page and look at we can see in the Taiwan, and it's a GeoJSON file. Okay, and so the same operation, I will give you 1 minute to tap this code of the GeoJSON. Okay, and then let's come back to our PowerPoint, and then let's do our second exercise. The viewing the climbing flight trajectory by flying on the web. So we have done the fly route in our second class. We have do the fly route in the desktop. So in the web browser, how to add the flying route. Okay, so in this exercise, and we are use this fly route file, and then we will add this KML file and add this flat file .pf file, adding our data. And then we will add the image entering data service and load the KML climbing route and load the flat route to realize the flat along the route. And then let's look at how to realistic this exercise. Okay, and we will use the interface that we will use is a fly manager. Use the system.flyManager, and under this there is a current route to get the current fly route. And when going to the and when we add the route in our fly manager, there have the ready promise. There have the ready promise where you can do the operation after the route is ready. You can do some operation after your route is already. And there also have the stop arrived. They also have the stop arrived to get the station arrival event. And we can also set the current stop index. We can also set the current stop, and that is the current station index, and get the index of the current station, or you can directly set it up and jump to the correcting site instead of the starting from first site. When we use the first method, the current route, to get all of the fly route point, and we can set it in the desktop. We can set it in the desktop and get the corresponding site here, and you can display it across to the wheel to stop. You can get it across to the wheel to stop and locate the corresponding site, and you can directly locate the set location. Okay, and let me repeat it. Maybe it's a little confused, and you can consider it slowly. Okay, so in our exercise, we will use the system.flyManager, and in this method, there have the current route, and we can get the current flat route from this current route, and it will use a method of the get all route stops, and it can get all the stops of the current flat route. And then there have the ready promise. When we add the fly route to the fly manager, and it will come back to the ready promise to get the ready status of the fly route. And it can use the wheel to stop to set its positioning. So for this method, we can use a play, pause, stop to set its status of our point. And then they also have the stop or wrap to obtain the our point, our station event, to get our station arrival events. And it can open some operation that after our fly when we arrived to the site. And when we get it station, get its event of the station, and we can set its current stop index. And the current station, that is a current station index, and get the index of the current station. Or you can directly set it up and jump to the corresponding site inside of the starting from the first site. So if you wanted to look at the station 2, or you can just to select the station 2 to look at this station. Okay, that will to view your station point. Okay, so when we so when the first method get all the site, and you can get the corresponding site, use the current stop index, and you can display it according to the wheel to stop located the corresponding site, and you can directly call or locate the set location. Okay, so how to carry out the flight development? How to do the flight development, and let's look at it. So first step, we should add the FPF flight file and initialize the flight management. So we should do the flight file in the desktop and save it to the project directory folder, and initialize the flight management. And according to the flight manager interface, and set the scene object and transfer the scene object. And through the viewer, the scene gets the scene object and pass it to the corresponding scene attribute. And root sets the path of the flight file, and here we use a root collection. We can see in there we can use the root collection of the system to set the simple objects of our flight path, flight route, and open the flight file through the routes .from file, and incoming the flight relative path of the file, and where the file with the flight path is set and passed to the flight manager. Okay, so maybe that's a config, and I'm gonna to repeat it. We are gonna to when we complete our FPF flight route file, and through the flight manager interface, and transfer it to the object, and set the object, the scene object, and through the viewer to obtain the object of the scene. And in there, it's use a system.root collection to set the object of our fly route, and it's use of fly routes. It's use of routes from file to open the fly file, to open our file of the fly routes, and it's transfer the path of our routes. We can see our routes is use the FPF URL to deter destination. Okay, and then set the when we finish to set the file of the fly route, and set it and transfer it to the file manager. Transfer the from file. Transfer it and let's transfer it to the file manager. And then let's set the registration site overall event through the stop attribute, and the the method of the add event. The method of the add event pass a callback function to them, and when we arrived at a certain set, and the content in the method pass a call in the function will be exalted. For example, we get the name from the correspond arrive site, and the callback function will return. For the current station information, you can cite the corresponding operation yourself, and there is a route stop wait name. That is, the wait name is a suspension time of the current station, and the station is a 360-degree turn to suspension time. Okay, and then there is a switching event of the site. In there, we use the jQuery selector, and first is judged whether the flight route exists, and the site index is obtained through the flight manager current route. From this method, gets the attribute of the current route and gets a set switch to the through route. And we transfer it to the stop object, and then flag manager dot current stop index as the index of the corresponding set. That is the index of the set to be reached, and the route through the will to stop the site objects obtained by route and gets, and it's obtain the station of the switch, and transfer it to the stop, and makes the flag manager and the current stop index set its index of the station. That is correspond index sets the index of the corresponding set, and the index of the set to be reached, and the route through the will stop, and the set object obtained by the get is passed to him. so that we can move the location of the correcting site. Okay, so it's more hard to understand. Okay, and let me repeat it and explain it. So that is a switch event of our station, and it uses a jQuery selector. And first it's judged whether the fly route is existing, and when we get the index of the station by the flag manager, and the current route get the current attribute of this route, and it's through the route dot get, and it gets the index of our stop, and it's transferred to the object of the stop, and it uses a flag manager and dot current stop index to set the stop of the index, and that is to get the stop of the inset, and it uses a will to stop to make the route dot get make this stop to transfer to it. So it's through the will to stop and transfer its information to the route dot get through the stop. So so that we can modify, we can change to the so that we can move to the location of the stop. And then we can reference the file of the code named fly route. Okay, this code I have sent to you by the QR code, and let's look at this code. And okay, let's look at this code. It's a fly route, and look at it. And I give to you the comment is in English, and in my folder it's in Chinese. Okay, and let's look at the corresponding code. And the loading container of the loading scene pass through this viewer dot scene gets the scene object, and then the models can be selected, and the set switching event is registered on the each operation, and click the one stop to monitor the time, and jump directly to the stop that you have selected. And then let me look at uses okay, I found it, and use route collection. Uses route collection to create the route collection file of flight route. It's ready to get the route of the file in the flight manager, and use flag manager dot use a flag manager dot ready promise dot then function to get to register the event of the stop reached, and then generates out of the list of the stop. Okay, and let's look at its result and its effect. Okay, and let's open our website and tap this flag route. Okay, and let's wait a minute. We can see that is our flag route, and there is our road and the tree. Okay, and let's look at this code, and we can click this play button to review our flag route, and click pause to pause, and click stop to come back to our first stop. And then let's click stop and click it to modify to our stop. Let's modify to stop 7. Let's to the stop 7 and stop 9 and stop 5. It can modify the stop file, and that is visible the flag route and visible the flag stop. Okay, and so today's homework and today's quiz, you should complete it flag route by yourself, and to generate to affect this page in your website. Okay, today's course is finished, and thank you very much.